Assalamualaikum warahmatullahi wabarakatuh, and a good day to all of you. First of all, I would like to thank the organizer of the 4th ICSTR Bali, which is the International Conference on Science and Technology Research. I am Dr. Rizafizah Othaman, the head of Polymer Research Center in Faculty of Science and Technology, University Kebangsaan Malaysia. These are the team members, and the title of my research today is a Ternary Deep Eutectic Solvent, or DES, Impregnated Silica Gel for carbon dioxide capture. So before I start, I would like to invite those who are interested to collaborate with us to look at our website, Polymer Research Center, at this address, or you can directly contact me at rizafizah@ukm.edu.my. So why we started doing this research is because, as you know, global warming is very problematic, and it is because carbon dioxide concentration is keep increasing year by year, and it believes that it increase around 3 ppm per year. And this creates so many problems, such as shown by these pictures. And there's an urgent need for us to reduce the carbon dioxide concentration in the air. And what is good about carbon dioxide? It is because we can change it to chemicals, renewable chemicals, and also we can use it as fuel. Currently, carbon dioxide capturing, there are two types or two methods to do this. It's either using a liquid absorbance, where it is reported that the advantage is a high absorption, or solid absorbance. The solid absorbance consists of so many materials, and the advantages of solid absorbent is that the advantages are high thermal stability and high porosity, but then the problem is it needs a high energy for regeneration. So in the research, we are combining liquid absorbent and solid absorbent, and we made it become a green technology according to a green technology requirement, because the material is biodegradable, it is cheap, it's non-toxic, and it can absorb carbon dioxide at high capacity, and also require a low energy for regeneration. So what we use in the research is called deep eutectic solvent, or DES, and DES is actually the eutectic mixture of two or more compounds. It's actually solid, so when we mix it at a certain composition and at certain temperature, it can melt, or it can become liquid at a very low temperature compared to its individual melting point. And in our research, we are focusing, we did try with so many types of DES, but for today's presentation, I'm going to focus on one type, which is organic ammonium salt, and with the amines or organic acid and polyols, such as choline chloride and urea. But instead of using just a binary mixture, which is common for DES, we are using a ternary mixture, where we add in a polyethylene imine, or PEI, as a deep eutectic solvent. So the composition for choline chloride, urea, PEI is 1 to 2 to 1, and we also compare it with a binary DES of choline chloride and urea, and also the PEI as a single PEI itself. And in order for us to make sure that it becomes a very good absorbent, instead of using it as a liquid as it is, so we mix it with silica gel. In this research, silica gel is regarded as SG200, So we combine these two via the wet impregnation method, and this is the pictures of our solid carbon dioxide adsorbent. So next, I'm going to move to results and discussion. This is the FTIR spectrum of the red one is the ternary DES itself, and the black one is for silica gel SG200, and these are the mixtures of ternary DES and silica gel. And as you can see, the peak here become broadened, and this is a peak for SiOH. That is, we believe that the change is because there's an interaction between SG200 and our ternary DES, and the interaction is like this, where there is a hydrogen bonding in between. So for the thermal stability, for TGA and DTG, the red one is for PI, the black one is for chlorine chloride. And as you can see, for PI, the peak shows slightly stable compared to the mixture, where the mixture is around 300. But then compared to chlorine chloride and urea, the ternary DES is actually stable, more stable. And then when we impregnated it with the SG200, in SG200, so this is the single SG200, and this is the composition of increasing ternary DES in the silica gel. So you can see that the weight loss is of course higher than the silica gel itself due to the ternary DES being removed. So the temperature, we found out that the adsorbent is stable up to 130 degrees Celsius. And for the crystallinity, this is the SRD spectrum as just one peak here. Okay, so there's only one peak for all of the adsorbent. So it was found that the structure of the silica gel remained. So the crystallinity also is, let's say, for SG200 is about 42% when we impregnated it with DES. So the crystallinity, it doesn't change too much. So it means that the DES exists as a thin layer of liquid on top of the silica gel. So this is for nitrogen and carbon dioxide absorption, desorption isotope. As it is slightly complicated to see with the just the graph, so we simplified it into the table here. So the BET surface area for SG200 is actually the highest. So when impregnation of the liquid is being done, you can see that the surface area reduced with the binary. It's also low, and even with the PI, it becomes lower. The total pore volume also reduced. The average pore size, it doesn't change a lot. But then for carbon dioxide uptake, it is very interesting to see that SG200 can, although it has a higher BET surface, or the highest BET surface area, but then the carbon dioxide uptake is just around 20. So when we mix it, when we impregnated the ternary DES, it increased up to 25%. It goes to 51 milligram per gram. So almost threefold increment. And then people might say maybe because it is due to PAI, so that is why we take PAI as a control, and we found out PAI can goes up to 48, but then with the Ternary DS, it shows that it has a higher CO2 uptake even compared to the binary system. So although there's a poor filling and thickening of a DS onto SG200, we found out that this ternary DS can absorb carbon dioxide at a very high capacity. And this is the highest one. So for CO2 absorption dissociative isotherm, from this isotherm, we come up with how the carbon dioxide been absorbed by our absorbent. So we assume that in the first place there is a chemical absorption or chemisorption took place, and then on top of the chemisorption there will be carbon dioxide absorbed physically. So absorption occurred after chemisorption. We did the analysis we did the further analysis for the 25% ternary DES impregnated in SG200, and then we found out that if we increase the temperature, this is for the effect of absorption temperature. So we use TGA carbon dioxide. And if we increase the temperature from 30 degrees Celsius to 85 degrees Celsius, the absorption capacity reduce. So it means the best absorption can be done at 30 degrees Celsius. And if we check what is the relationship between the carbon dioxide and the temperature, it is almost straight line. With this equation. So it means that the best temperature to conduct the absorption is at around 30 degrees Celsius. After the absorption, we then dissolve it, where we increase the temperature once at 100 degrees Celsius. And then after that, after we increase it, we just retain it inside our system, our reactor, and we found out that for the absorption temperature at 30 degrees Celsius, it needs around 80 degrees Celsius, so around 25 minutes to completely dissolve things. And then for the absorption temperature at 85 degrees Celsius, the dissorption temperature where the carbon dioxide completely dissolved is just 91 degrees Celsius, and the duration took around 3.5 minutes only. And then when we try to check it, because previously it is 100% carbon dioxide or 100% nitrogen, but then when we use mixture to check the selectivity, this for 15% carbon dioxide mixed with 85% nitrogen inside the reactor connected to GC, and we found out that at 3 times experiment, our absorbent can absorb carbon dioxide around above 40 milligram per gram, so it's capable to absorb around 90% of its capacity. Because the highest is 91 only for 100% carbon dioxide, but when it's a mixture, so there will be a competition between carbon dioxide and nitrogen. However, it still can absorb more than 93%. So this is the regeneration using Assoc 2020. We degas it at 80 degrees Celsius for 6 hours, and we've done it up to 8 cycles, and it's found stable up to 5 cycles, and it's slightly, just slightly reduced after the 5th cycle. But then the carbon dioxide absorption capacity is still high all along the cycle. So we just want to prove either our mechanism about the absorption is correct or not. So we check with the XPS, and this is for carbon 1s, is for nitrogen 1s, oxygen 1s, and we found out that there's a new peak after the absorption, which is the carbon, carbonyl, CO, CN, and the carbamate, and also the carbonyl. So that is why we propose that because they will be the reaction for primary amine, secondary amine, and tertiary amine with carbon dioxide. So all of them, not all of them, only the primary amine, secondary amine will result in the carbamate, and for tertiary amine is going to result in bicarbonate. So in our case, the primary amine, the secondary amine, we only change to carbamate. So that is why we propose that at first it is chemically absorbed, and some of it there will be on top of the chemically absorbed one is a physisorption, and also there are physisorption and chemisorb only occurred on top of the impregnated ternary DS impregnated SG200. So as a conclusion, I would like to say that the best adsorbent in this research for ternary DS is when the composition of ternary DS is 25%, because it can absorb carbon dioxide, 100% carbon dioxide, 51 milligram. However, so if the composition of carbon dioxide in the air is reduced, then it still can absorb more than 90% of its capability, and the highest uptake of carbon dioxide is 51 milligram per gram, and the stable temperature is 30 degrees Celsius, and these are the references. And for the acknowledgement, I would like to acknowledge University Kebangsaan Malaysia and also the higher Ministry of Education for providing us research grant, FRGS, and the Green Tech Sendirian Berhad, Green Phoenix Sendirian Berhad for the industrial grant, and Polymer Center for technical support, and Center for Research and Instrumentation Management of UKM for the instrument facilities. So that is all. Thank you very much.